Dear students, in the previous class, we have discussed first colligative property, that was relative lowering in vapor pressure. And in that property, we have seen that on adding non-volatile solute, the vapor pressure of the solution gets decreases. Here we are discussing the second colligative property, that is elevation in boiling point. Now, what is boiling point? It is the constant temperature at which vapor pressure of any solvent becomes equal to atmospheric pressure. Now, we will understand this property with the help of the graph, that is the graph between vapor pressure and temperature. The graph between vapor pressure and temperature. As we have seen that when the temperature increases, the vapor pressure of any solvent increases. So this type of curve we get, that is, on increasing the temperature, vapor pressure is also increasing. Now, what happens when we add the non-volatile solute? When we add the non-volatile solute, then we get this curve. This is the curve for the solution, that is the solution in which we have added non-volatile solute, and this is the curve for solvent, pure solvent. This is the curve for pure solvent, and here in terms of temperature, this is the point TB naught, that is the boiling point of pure solvent, and this is the temperature for solution, that is TB. Now this is the difference, that is delta TB, between the two boiling points, that is pure solvent and solution. So here we can write down TB naught. What is TB naught? TB naught here is the boiling point of the pure solvent, boiling point of pure solvent, and TB is the boiling point of the solution. And here delta TB. What is this delta TB? It is the difference between TB and TB naught. So here delta TB is elevation. It is the elevation in boiling point, or we can write delta TB is equals to, it is the difference between TB and TB naught. So TB minus TB naught. It is the elevation in boiling point. So we can understand it by the graph that on adding the non-volatile solute, there is an increase in the boiling point. Here there is an increase in boiling point, that is from pure solvent it is getting increases. That means the temperature is getting increases and this boiling point is getting increased. Now mathematically we can write it down. Delta TB is directly proportional to m. So here delta TB, on removing this proportionality constant, here we will get Kb and into m. So here this Kb is molar elevation constant, or we can say it as ebullioscopic constant. It is ebullioscopic constant. Now this delta TB, we know that this delta TB is directly proportional to m, that is molality. Delta TB in terms of molality can be written as here Kb into Wb by Wa into 1000 and divided by Mb. So here this Mb is the molecular mass of non-volatile solute, So with this formula, with the help of this formula, we can easily find out the molecular mass of a non-volatile solute, and that's why we are saying that elevation in boiling point is a colligative property, because it is depending on the number of solute particles.